Right, well, at the beginning I said I'm not sure if I've done this right. Well, I dropped the bollock. Right guys, today's episode is the finale of the how to frame a bastard hip roof, and I'm not going to lie to you, even I'm not sure if what I'm about to try and do is possible, so you might have to bear with me. There might be some errors along the way, we don't know. And I've been doing this 20 years now, and I don't even know if I've done one of these. I've done bastard valleys, but because it had a vaulted ceiling, I couldn't, at the time, this was years ago, I couldn't work out how to get the equal soffit on the outside of the building, but get the ceiling, the vaulted ceiling, to run in line with the corner of the inside of the building. As I'm going through this, you'll see how that is such an unusual thing to try and do. And I've been thinking and thinking and thinking, sleepless nights and all that, but have I done it right so far? So we'll soon find out, but all that will become apparent as we move along. The worst case scenario, I can't have equal soffits on the outside and the vaulted ceiling to run into the corner of the inside of the building to make that look right. Yeah, the most important thing, if I can't get equal soffits and the ceiling to hit that point there in the corner, is basically, I think you've got to make it look right on the inside, haven't you? And if we have to have unequal soffits on the outside, that is just going to be what it's going to be. So this will unravel as I go ahead, but my first port of call is I cut these rafter ends to suit a 200mm soffit, and even that might have changed now. I might even, you don't see it very often, but I might even do an angled soffit. But anyway, that's irrelevant as long as you find your corner by coming equidistant off this face and equidistant off that face. The line of the hip should stay relative no matter what distance you come off, as long as they're the same. So I'm just going to mock up something out of a bit of MDF, because it was originally going to be a 200mm flat fascia. I came 205 to give me that bit of room so you don't have to bother scribing in or anything like that. So my first port of call is to set up a corner here, 205mm off that face, 205mm off that face, and go from there. Right, so I sorted the first bit, right? So this is nothing to do with the height of our rafter now. It is the line of our hip. Sorry, height of the hip. It's the line of the hip. Okay, so I'll show you what I've done. So I've mocked up the corner of our building, which is going to be there, because that's a 205mm. Okay, I've just screwed it to the top of the blocks, and I've get as above height here, I've just plumbed a piece of block of wood up, and then I've used this piece on the top then to hold it plumb in all directions. And then I've put a little saw groove very corner, and basically I've strung my rafter line, and I'll show you where that goes. It doesn't go into this point here. I'll show you where that goes now. I hope you follow that. So yeah, and what I did was I put my 205mm mark there in line with the block, so I know that's 205mm, that's 205mm. That's perfectly plumb in all directions going up, so that is an accurate reading of the corner point of our building. Okay, yeah, and here I've had to nobble this out with the handsaw because I couldn't tell whether it was fouling the string, but basically you can see where I've packed off with that packer. So our string line needs to go to the back of this wall plate and the back of that wall plate, which is that pencil line there. If you see, not this one, not the back of the packer, but the back of the wall plate, that pencil line there, which lines through nicely with that bead actually. So that's the first step. Then I've got a bit of 8x2 offcut, and if you can see now, I have lined that through, and I'm pretty confident that is bang on the line. Okay, the line of the hip. That's not the center of here. If it was a 45 degree, it would be, because when you cut your bevels at the top, it would land in the middle of the timber. As you can see there, that string does not land in the center where the king common and this common rafter meet up. So it's not the center of the timber, so that's our offset. Oh, I hope that makes sense. So what I've done is I've drawn my line, and now I need to establish the height of this hip, which is where I think I might have gone wrong. But in my head, I've done the height above plate here on these rafters exactly the same as the height above plate on these rafters, but I think that's where my issue lies. Yeah, but as you can see, nowhere near the corner of the building, so this is where I don't even know if it's possible. I'm attempting to do equal soffits and then for the ceiling to run into this point here, and it is absolutely miles off. Right guys, so I set up my string line, didn't I? So I needed to work out the offset. I didn't necessarily need to do that right away, so I'll come to that in a minute. Basically, from center line, I've gone 22.5 mil that way, and that means my rafter, or my hip, sorry, should I say, will finish. So I don't know if you can see, I'm on that 22.5 mil line, and it's running through the center up to the point we want there, right? So that's how I've got that position. And then what we need to do, I'm going to do a dummy rafter first. So in order to cut that, we need to find the top of our rafter, don't we? That end's fine because we can just plop it on and rest it where they both meet. Look in the corner there. But this end, we need to work out the distance from there to where it intersects. That was 365 mil. So what I've done, so I've screwed a piece of MDF onto there because we need, where this lands, we need to land in relation to this one here. So I've leveled across from the top of the wall plate, and I've measured 365 from the back edge of the wall plate to there, and then I've plumbed up, and I've measured what that distance from the top of there to there is, and that was 200 mil bang on. So I've cut myself a block 200 mil, sat it in the line that we need it. That will be where the back edge of the wall plate intersects with our hip, and then I've flicked that so it's center. Ignore this bit because that's completely in the wrong place. That was just to set our line, but to this point that string should be represent the top of our rafter. So if I come down, you see that? That's lovely. Yeah, that's perfect. So I'm happy with that. I'm just showing you how I get the offset, because you see that doesn't go through the center where they intersect. So I've got this. Okay, so first of all I'll show you how I'm going to use it, and then I'll show you how I got to these cuts here. Okay, so it's a bit backwards, but I can't be bothered to undo everything because at the moment I've got my hip in place. But what you got to realize also is that isn't the top of the rafter there. The top of the rafter is where they meet the top of these rafters. So what I'm going to have to do is hold it there somehow. But basically, can you see that? That's how it's going to sit. I've just marked, don't know if you can see it, I've just marked it there. So I need to get the end of that rafter there to sit on there. I'll do it and then I'll show you. There, you see? So that is intersecting the top of that, yeah? Get me? So we're bang in the right place now. So now I'm going to work out the pitch of this hip using my angle finder, and I'll tell you what it is now. So the pitch of that hip is 13.5 degrees. So that will enable me now to do the plumb cut and the bevels. And to do the bevels into that corner, I'll just explain before I move everything how I work that out, okay? So just to rewind a bit, right? So if you remember this string line from there to the corner of the building that we want to be is that line. So then this line is 22.5 mil, which is half the thickness of my rafter. I struck them across, but to get that offset dimension to finish in that corner, in order to get these angles then, so from our struck line, I squared off this line in either direction. So if you imagine that is now 90 degrees to that line, and then all I did was get my adjustable roofing square until I got that angle there, which is pretty much bang on nearly 60 degrees. Okay, so let's just call that 60 for argument's sake. So all right angle triangles need to add up to 90, don't they? So that is telling me that the other angle is 30 degrees. Okay, but because you've got this adjustable roofing square, it also works like this, look. So if you put that on the plumb cut, that gives you that angle. So our two angles were 30 and 60. So remember that. So if this represents the center line there, what I did, I measured from there, which was 20 mil, right? So if you remember the 20 mil, now this is the piece I cut. So that is the center line of our rafter, and all I did was add 20 mil to get to that point there. Right, so that's the cut. So we've got the 13.5 degree plumb cut, the 60 degree bevel, and then the 30 degree but that should actually be a right angle, which it is. If you measure it this way, because the 60 and the 30 added up to 90. So I was going to do it on my Milwaukee and make a jig to do the oversized bevel, but it wouldn't even cut through that. I ruined it on the last video when I did the green oak frame, so I'm going to have to get a new blade for that. So unfortunately, well, this ain't much better either because that got a batter in, but I did it by hand. I'm going to have to get a new handsaw as well. But yeah, I just cut this by hand. I'm going to try him up now. So this end should just flop into the top, yeah, and then I've just got to pack it up so that the other end is 200 millimeters above wall plate. Right, well, you know, at the beginning I said I'm not sure if I've done this right. Well, I dropped the bollock. I have done it wrong, and I've just realised why. So I'll try and explain so you guys don't do the same thing. So here goes nothing. I'll show you. So I clamped my thing in there. I don't know if you can see. Beautiful. Then this is in the right spot. That's 200 mil above wall plate height, and then you drop down here, and it is absolutely perfect, right? But this is where I've gone wrong. What I've done is I've got the height above plate on them the same as them, and that was my rookie mistake. Okay. That's where it all went wrong. What I should have done is this before I even did them, which means the height above plate on all of these should have been 200 mil. I can't really change them. The only way around that would be to cut fillets, some almost like flat roofing fillets, from nothing to however much short we are. So I don't want to do that. But at the moment, on the inside, so the ceiling joists are miles off the corner, okay, and we don't want to see that from the inside. So what I've realized is what I did there, getting the same height above plate there and the same height above plate there, does actually work if I run my hip through there. Yeah, which means in order to do that, it will leave us with unequal soffits. But does that really matter? And is it even possible to do both? Equal soffits there and a ceiling line that runs into there. Perhaps someone could help me on the comments and comment whether that is possible, but I'm just really annoyed with myself. Kind of messes up my how-to video, really. But you live and learn, don't you? I mean, cracking job this way. Just that way, we're too low. So yeah, that's what I'm going to do. So I'm going to have to restring this to that point instead, and we'll just have to have different soffit sizes on the outside, which, to be honest, is not the end of the world, is it? So I better crack on and do that. I can't believe I've done that. Sorry guys, learn from my mistake. Right, so this is take 2. So I've strung my line into the internal corner, which is that line there, as you can see. So 22.5 mil that way, 22.5 mil there, and this is my 108 mil height above block plate, and it's going to touch the back of the wall plate there. So this will be like a normal thing where to make your square bird's mouth, you just nip the end off the wall plate with your handsaw. So now I'm going to screw this in here, cut the end off my dummy rafter, rest it on top again. But at this position, I will cut a bird's mouth into this one now, which will be to leave 108 mil above wall plate, and I'll see if I have any luck this time. Well, straight away, piping my string back down there through the centre line-ish, and I come down to eye level. That is spot on now. So yeah, that's my error. I was working to the wrong height above plate on this run. It should have been 200 mil, not 108, which is what this is. So hopefully this should all work. At least we'll have a nice ceiling on the inside, and we're just gonna have to live with the unequal soffits. But at the end of the day, I'd rather look right in the inside than the outside. Phew. So I got my new hip in now, and we come down. It's lovely that way and lovely that way. Yeah, it's worked out spot on. And now our ceiling will run into meet this corner now, which is what I was actually aiming for. So I don't think it's actually possible. So the universe works in funny ways, doesn't it? So if I'd have set out these rafters at 200 mil above wall plate height, right, to achieve my equal soffits, then when I got to this point, I'd have discovered that it would be impossible for the ceilings to line through. So in a way, I think I was meant to get that wrong, because I don't think it's possible. So, you know, if anyone's done this or achieved this, I'd like to know, just to put my curiosity to bed, really. After I realised it was wrong, retrospectively, it was bloody obvious it was wrong, wasn't it? Because how can you have a hip that's 200 mil above wall plate to the top of the hip when your rafters are 108 mil? So, yeah, looking back at it after the event, it's bloody obvious, you sausage, Tom. But it's all worked out great, because it's beautiful now. Anyway, I'm going to crack on with these jack rafters. So I'll explain how that's going to work now. I'll show you how I work out the bevel cut now. So I've got my little framing script. I've put that there. So that is 66 degrees, which means the other side of the bevel then will be 24, which brings us up to 90 degrees. So the jack rafters on this will have a bevel cut at 66, and then back to the normal 16-degree plumb cut for the bird's mouth and seat cut. So in order to cut this first jack rafter, I've squared across there to 400 from left hand side of rafter to left hand side of rafter, measured 400, which gives you 400 centers. Then also marked it on the bottom, and I've measured from the back of my wall plate where the bird's mouth will sit up to here, and it's given me 2110. Just cut my bevel. So if you think about it, I set my little thing, didn't I? So that is from this side. That's our bevel. So that's our longest point that touches that pencil line I've just made. I put my tape on the longest point, come down to 2110. Have I? Oh, I've slipped. That's right. Better remark that because my tape slipped. Hold on. So now, if you remember, I've set that to 16 degrees now. So I need to get 108 mil. Need to measure 108 mil because that was our original height above plate, wasn't it? Until it intersects this point here. Okay, so I'm going to do that now. That point there to where it intersects this first line here, that's 108 mil height above plate. So we just need to connect our seat cut then. So that's our seat cut there. Okay, I'll cut that out now. So that's my bear's mouth cut. I'm just going to go and offer him up and see what she looks like. That's seated lovely. Lovely and tight there, and dropped onto my wall plate nice. And now what I'm going to do now is measure the next 400 like I just did. Measure from the back of the wall plate up to there, and then the difference between them should be what I deduct off the last one. But as it's so small, I think I might just measure it just in case. That's my jack rafters fitted in and fixed. So I've now got to start this side now. So I'm going to mark out my wall plate 400 centers from that one until we get to this end. So the plumb cut on the double bevel on the compound cut there, for this one you do this pitch of roof, which was 16 degrees, and for that one I do 29 because that's the pitch of that roof. So now I'm marking out this run now. So it's a 29-degree plumb cut, and then we already set our angle, didn't we, for the other cut. So we marked the last lot off this side. So this time we mark it off that side, and it works out to 90 degrees then. That's what my next compound cut looks like. Right then guys, I've got all my jack rafters in now. I'll show you in a minute. Really today's job is getting all the boring bits done up to reg. So I'll just run you through what we've got to do. So that is my hip, and it's going through the corner of the inside of the building, and that has left us with another problem to get over, because these are such a different pitch. I think there's over 10 degrees difference between the two pitches. The soffits are massively different sizes, but I've come up with a funky design idea that the customers are contemplating at the moment. So I won't tell you what it is yet, just in case they just don't agree to it. So today's job, what we're going to do, gotta fix all these, and fix all these. I framed the velexes, but they need the little rafters put at the top and the bottom. I've done my supported restraint straps, so can you see the strap sticking out there and there? You can do this either on the bottom or the top, it doesn't really matter. I just done it on the top because it's easier to work down, because what you have to do is you have to cut these noggins slightly, not as wide, so the strap runs across without fouling, because I've done it before and not bothered, and then typically it lands bang on a batten spacing and it fouls it. So yeah, what you do is you set these about, I don't know, 5 or 6 mil below the top of the rafter height, and then just chisel out the tops of the rafters going this way so it sits flat and flush to the roof. So they get built in then behind your block work. That's that job done. I've got to bolt all of that to the wall. I've also got to try and bolt all of that lot. That's another job. I've got to bolt all my doubles together. You should really use joist hangers off these, but do you know what? Is there really any need? So I'm just going to use these big 150 mil structural timber screws and screw through into the end of the rafter. I mean, that's plenty strong enough. I'm not being funny. We had a proper tight squeeze because on the drawings it was an 1180, so I've had to really try and squeeze this big velux into that space, and it was a little bit awkward. So I had to work out all my batten gauge and everything. Also got to build up this gable end here and do all the cuts on the infill in there, put the insulation in up to the height of the insulation that's going to go in between the rafters. So there's a lot fire socks as well. There's lots to do. So I'm just fixing my first wall plate strap. I usually go just in from the bottom, and then I go diagonal. I miss one, miss one, miss one, miss one, this one. Make sure you get plenty of screws in there. It's just red plug, 50 by 5s. I don't know about anybody else, but I never use brown plugs. I always use these for 5mm screws and 4mm screws because you get a really good fixing, and they've never let me down. So I would avoid buying the cheap red plugs because they're a bit crap, really. I always opt for these. The big tub of 1,000, I think. Yeah, good they are. Now, they're supposed to be no more than 2 meters apart, these straps. So you just got to work it. At the end of the day, got a big opening there, so I'll probably just whip them off with the grinder, and that will act as my straps there. Same there. I'll put one down that flimsy, well, it's not flimsy anymore, but column there, and then probably 1, 2 on the ends. Right, I thought I'd show you these. I'm doing my bolting my wall plate at the moment to the house. I've been using these for a while now because they're brilliant. They're a bit more expensive than obviously buying a tube, but those tubes don't really cope well in a standard skeleton gun, mastic gun. The amount of times the actual handle is just buckled and crippled, and if you buy the specialist, more heavy duty ones, sometimes there's a compatibility issue if you buy a different brand of chem fix. So I get these bad boys, and you get 10 in a pack. It's so much less effort. So you drill your hole. So this is for an M12, so that's a 14mm capsule you need. Drill your hole, blow it out, and I got a little hack for that as well. Rather than those silly little blowout pump things, I got a metal straw here that I just yoinked off my customer, and I attach it to the end of my blowgun on my compressor, and that whooshes it straight out. So yeah, a little tip there. And then, yeah, you pop your capsule in the hole. And what I do then is you can buy the more expensive resin studs with the nut driver on the end. But I just use these, and what I do is I put the nut and washer on. The spiky end pierces the capsule, and then you just drive it in with a drill. But because these haven't got the nut driver on the end, I just chuck it in the chuck of my drill, tighten it up, and then whiz him home. Little tip there. It speeds up the process so much, and you don't have a flipping wrist cramp from trying to squeeze the bloody chem fix out on a mastic gun. Thought I'd share that one. Right, dudes. Thought I'd jump in at this point because as I was editing this, I quickly realised that it has the potential to completely confuse the hell out of you. So I thought I'd summarise this episode and point out a few things I've learned along the way and how to deal with these bastard hip roofs. So I'll break them down point by point for you. Point number 1, never do a 3-part series if you haven't filmed them all and made sure what you're trying to achieve is possible or correct. So that's point number 1. Point number 2, if you're in the building game or you're a trainee or an apprentice, things don't always go to plan. And the most important thing is don't panic. Or in Welsh, as they say, dim panic, because there's always a way out. You just got to hone your problem solving skills, and the better your problem solving skills become, the better a tradesman you become, okay? And no matter how long you've been doing it or how little you've been doing this building game, then you're always going to come across problems, okay? It's just inevitable. There's so many variables. When architects draw these unusual details, there's no detailed explanation on how you're supposed to carry that out on site, so usually it gets left to muggins to work it all out on the fly. So that's point number 2. There's always more to learn. Point number 3, I've realised unless someone can correct me in the comments, I've realized that what I was trying to achieve with equal soffits and fascias on the outside of the building and the vaulted ceiling to run through in the corner of the inside of the building, I don't think it's possible at all. Because I've thought about this. Honestly, it's been driving me nuts, right? Thinking, what could I have done differently? I think on the video I mentioned cutting tapered fillets on the top. Apart from being a load of work, I realised that wouldn't work either because, well, two reasons. It would change the angle of the roof that you've already put in, which would mean the hip that you've just done would be wrong. It might be right at the point where it crosses a little wall plate, but the rest of it would be wrong. Also, you'd have a gigantic fascia at the bottom of the roof, so that would have been a no-go. The other way was if I did the correct 200mm above wall plate height along that long stretch of roof to get the soffits equal. I thought, oh, that's what you do, whatever the difference is. So it was originally 108mm above plate, and this side was 200mm above wall plate. I thought if you put a double wall plate on, it might even have to be a triple wall plate in order to get a decent bird's mouth. All you'd have to do is find the difference between those two wall plate heights and then pack the ceiling on the inside. So for example, it would be 108 and 200, that's 92mm difference. So, you know, maybe trim down some 4x2s and screw them to your rafters internally, and that would make everything run in line with the hip. But if you think about it, if you do that internally, then at the bottom of the vaulted ceiling it would run lovely, but at the top where it meets the original house, then it would move the position of the ceiling off the corner at the top of the roof. So I was just chasing my tail, man. I'd love it if anyone's achieved this before. Write in the comments a little explanation, because there is absolutely zero, zilch, nada, or in Welsh, dim information about this online. The only thing I managed to find was some American dude that said dry liners packed it out plasterboard, but I'm thinking, nah, it's like 100mm difference. I think that's the biggest problem because pitches are over 10mm difference. So the difference in the soffits on the outside were massive. So even though I got over the problem, it then added another problem. Because I researched it, the maximum unsupported eaves overhang you allowed is 610mm, right? And even at 610mm on the shallowest pitch, right? The steeper pitch only had a soffit of over 100mm, and that ain't really much eaves protection to the masonry below. And I didn't put cavity trays in, did I? Because it was going to have ample eaves protection, and it just didn't look right. It looked ridiculous. 610 one side, 100mm on the other side. So this fancy schmancy cool detail I came up with that I didn't disclose in case the customer didn't want in this episode, they've agreed to, and I think it's pretty awesome. So basically, as I was explaining our problem to the customer, Andrew's wife said, I quite like the overhang because it means you've got a bit of shelter and you can leave the doors open even if it's raining but warm. Or so I said, oh, well, 610 is something and nothing really, isn't it? It's not really a shelter. It's not really, you couldn't sit out there. So I suggested, why don't we embrace the madness and go to town on that eaves overhang? So I said, look, our proposed path round the building is going to be 1200 wide. So why don't we go nuts and extend the roof to 1200 overhang at eaves, right? Bear with me. And then what we can do is, because they were so pleased with the oak frame, we do another oak frame to support the eaves overhang and make it like, you know, like old man on the back porch, what the Americans do with the, what do they call them, a veranda maybe? So like a veranda detail, so they can have some bench seating out there and enjoy a sit down and a drink whilst it's raining and be completely dry. Found a picture online to sort of show you what I'm trying to explain here, so I'll put it up there now. So hopefully we've solved all the issues. So in a way, the nightmare I had trying to achieve the unachievable has turned into a pretty cool design idea. So everyone's happy, I'm happy, the customer's happy, it's gonna look cool, and I'm looking forward to doing it because I enjoyed that oak porch that I just did. So get a chance to do another one. Final point, and then I'll stop waffling. So how to deal with these bastard hip roofs. So if you're trying to do a vaulted ceiling like I did, what you want to do is follow the video to the T and get your height above plates the same on both runs, and that will give you the vaulted ceiling to meet in the corner of the inside of the building and unequal soffits, which you just have to tar up or dress up to make it look nice. If you want to achieve equal soffits on the outside of the building, then follow the steps. So start with your lowest pitch roof, mine was the 16-degree one. Get those common rafters cut in, then work out your hip. Okay, so follow the first lot of instructions I did about the hip detail, which ended up at 200mm above wall plate height on the perpendicular run. Then cut your common rafters at 200mm above wall plate height, and that should all work out. But you probably will have to either double up or triple up your wall plate in order to cut a bird's mouth into your rafters, and that will only work, I believe, again, unless someone can correct me, that'll only work if you're having a flat ceiling, so none of that detail will be seen. So hope you enjoyed this episode. I'll see you on the next one.